Hello students, we are going to do class 10 circles chapter. First we'll start introduction and the theorem we'll doing. Introduction, as you have learned in the lower classes students, what do you mean by the word circle? So circle, we know the word center comes and the radius comes and we use compass to draw circle. But when we say actually it is a collection of points, we can define circle as a collection of points which is at a fixed distance from the fixed point. This is a fixed distance and this is a fixed point. So both are fixed. The distance from a fixed point to this point, they are fixed. So it is a collection of points which is at a fixed distance from a fixed point. Now here, this collection of points is nothing but the locus. So we can define a circle. Locus means a collection, like we say, like a rule, like a bunch of grapes. So this collection of these points is said to be locus. So locus of points that are at the fixed distance from a center. So this we call the circle. Now in circle we have learned many things, like we know what is radius. We are very aware that the radius is defined as the distance from the point on the circle and the fixed point, that is center. So distance between the center and any point on the circle is called radius. A circle can have infinite radius. Similarly, you all know the diameter. So here we can say AB. So the segment that is passing through the center, and this is which is joined from any two points on the circle. The segment that is formed from any two points on the circle and which passes through the center is called the diameter. If you take any 2 points on the circle and if you join, then we can say it to be a chord. But what is the difference between the chord and the diameter? Diameter passes through the center. Chord doesn't pass through the center. So AB is a chord? Yes, AB is the longest chord. AB is the longest chord. So chord is basically is a segment that is joined by any 2 points on the circle. Segment formed by joining any 2 points on the circle. Joining any 2 points on the circle is called chord. Any 2 points on the circle. Similarly, this we have learned about this chord. Chord is a segment. If I extend this chord and now this has become a line. Now suppose I define this as line L. Now this line L is specifically called as secant. It is called as secant. So is CD a chord? Yes, CD is a chord. The chord is a part of the segment, secant. Chord is a part of the secant. How will you define a secant? Now here, chord is a segment, whereas secant is a line. Secant is a line which intersects the circle at 2 points. Secant is a line which intersects the circle at 2 points. If it intersects 2 points, then we say it to be secant. Now here the secant is defined. So here we can say this is a secant, this is a chord. We have learned this. Now similarly, now we are going to learn a very important other definition, that is this is a line. What about if this is a line here, imagine that L is a wire. Imagine that L is a wire. Now this wire is the line L. I am holding at this point, fixed point C, or we are just kneeling it. So with the black, we are just kneeling it. And this is a loose end which I can move it. So suppose if I move this line L, so here my D dash will come here, then my D2 dash will come here, then again it will come here. So here if I just say, now this line has been suspended, that means this end is suspended. You can find it will cut here. At one point you will find that the circle and the line has only one relation, that is this point. This line has got a special relation, that is this line is called, students, tangent. So tangent is a real hero in this chapter where you're going to learn the properties. So tangent, we can say it is a line which intersects the circle at one and only one point, which intersects the circle at one and only one point. So here we can say, can I say that a secant is a tangent? Yes. Actually, we can say tangent is nothing but a secant, where now secant is intersecting the circle at 2 points. But the same secant, if I just pull here in the side to the extreme end, you will find that they are coinciding, and then there is only one point where it is the circle and the line is connected. So this line becomes a tangent. So tangent is nothing but is a line which intersects the circle at any one point. This word can also be replaced by tangent is a line which touch the circle. And you know the name this tangent has been derived from the word that is tangerine. Tangerine. And this tangerine is nothing but the meaning touch. So touch means it has only one relation at only one point. So you can define it as tangent. It is a line which intersects the circle at only one point. At any point, no, sorry. It is only at only one point. I'm so sorry, I said one point, but I wrote at any point. So it is a line which intersects the circle at only one point, or which touch the circle at only one point. Now here, this particular C has a very special name. This point C is the only one connection. So this point C is called as the C is point of contact. C is called as point of contact. I hope you have understood the meaning of tangent, secant. So secant is a line which intersects the circle at 2 points. And here we understood tangent is nothing but it is a line which intersects the circle at only one point, one and only one point. It also means touch the circle at only one point. If I ask for a circle, how many tangents can be there? You can say from every point on the circle, if I take, as you know, that it's a collection of circles. So from one point I can draw a tangent, again I can draw a tangent. So a circle can have infinite tangents. A circle can have infinite tangents. A circle can have infinite chords. A circle can have infinite diameters. So similarly, it can have infinite tangents. Similarly, if I say that I have a tangent at point C, how many tangents can be drawn for this particular tangent? If I say C3 double dash, or I just give this name as E so that more specific. See, for tangent CE, for tangent C, which is in black, which is how many parallel tangents can have? It can have only one tangent. That means we can have at most two parallel tangents at most. We can have only two parallel tangents at most, students. Okay, I hope this is very clear to you. Let's understand the relation between circle and a line further. In this chapter, we are going to learn more about tangent only, students. Now here there is a diagram which says very beautifully a relation of circle and a line which we have discussed. Now here you can find, students, a circle is there and a line is there. Now here we can find there is no relation between circle and a line. So therefore we can say it is non-intersecting line. Whereas in the second case, you can find that a circle can, so either the line will not intersect if the line is intersecting at 2 points, for example, now here AB is a line and it is intersecting the circle at the point M and N. So this is called a secant. It is called a secant. If the line is intersecting or touching the circle at one and only one point, then this our hero name is called as tangent. And what is this point P called as, students? It is called as point of contact. So here a circle and a line can have the relation like it is non-intersecting. If it intersects at 2 points, we call as secant. If it intersects at one and only one point, we call as tangent. We will learn a very important theorem regarding this, and very important from the board point of view. Let's understand the theorem, students. The theorem is a tangent at any point of a circle is perpendicular to the radius through that point of contact. Let's analyze the statement. The tangent at any point of a circle is perpendicular to the radius through the point of contact. So here, as we say, we have to analyze what is given to proof of doing this. Tangent at any point of a circle. So we understand that there is a circle. So let's draw the circle. So here there is a circle. A circle is there. A tangent, it is at tangent at any point of a circle. So we'll take here. Let's take some different colors. So let's take and from here there is a tangent, so I draw a line. Okay, so let's take this point as AB. So there is a circle, let's assume the center is O, a circle with center O. There is a tangent, so tangent AB, and the point of contact is P. So given is that there is a circle with center O, tangent AB with P as point of contact. You have to prove that the tangent that means AB, at any point of a circle is perpendicular. It is perpendicular to the radius through the point of contact. Now here I can say the radius is actually OP. Here OP is the radius. OP is the radius. So you have to prove that OP is perpendicular to tangent AB. Okay. So let's first jot down the given. So here we know given is a circle with center O. So for given it is half mass. So definitely we have to write given formula. Center O. Tangent AB. So there is AB is a tangent AB. So we can say AB is the tangent to the circle. Is the tangent to the circle with P as point of contact. With P as point of contact. So here we have a tangent, a circle. Okay. So here we have written a circle with center O. AB is a tangent to the circle with P as point of contact. Now we have to prove that the tangent is perpendicular to the radius. So OP is perpendicular to tangent AB we have to prove. OP is perpendicular to tangent AB. You have to prove that the circle with center O. So AB is a tangent to the circle with P as point of contact. So you need to prove that OP is perpendicular to tangent AB. Now to prove this, let's have some previous facts which you need to understand to prove this. Now you have learned in standard 9 students that if a line is there, if you have a line and if you have a point outside the line, if you have a line for example L and there is a point P which is not on the line but it is outside. If I find out that from P how to reach the point L, there can be different ways, and say that you can go from here. Imagine the P to be a boy or a girl and want to reach this ground level, want to touch this line. So here we can go from here, we can follow this path and just follow this path. But if I just give an inquisitive that you have to reach within the shortest time and then you're going to get something, then I think the smart person will carry the straight distance, because the straight distance will be the shortest distance, and this shortest distance is nothing but the perpendicular distance. So if you go through this PA path, it will be easy rather than if you go by PB, PC, PD, you just name this EF. So it will be longest path. So here we have learned that of all the line segments that are drawn from a point P, to the line AB, the shortest distance is, here we can say the shortest distance is AB, the shortest distance is P, and the shortest distance means the perpendicular distance, and that is perpendicular. So here students, if I want to connect this particular theorem with this, if I want to prove that OP is perpendicular, I have to prove that OP is shortest. So if I want to make a comparison with OP, I require another point to compare. Let's take a point Q. So I'm taking a point Q on AB other than P. Okay, and then I will join OQ. So here construction, you have to remember that if I want to say that OP is perpendicular, and that means I have to prove that OP is shortest. So to prove OP is shortest, I require another segment to compare. So I'm just marking the join OQ. Okay, so let's write construction. So here the next thing after given to prove will come the construction. So here construction we are writing. Here construction is take a point Q. Taking a point Q on tangent AB other than P. Now why this is important other than P? Means we have to show that P and Q are distinct points. Then join OQ. Okay, now we have joined OQ. Now it is intersecting the circle at some point. Let us be R. Join OQ and let it intersect the circle. Let it intersect the circle at point R. Intersect the circle at point R. Okay, So this construction you have to remember. Now what is our aim to prove that OQ is greater than OP or OP is less than OQ? Now here we start with the easiest proof. So here we know students how much we have to prove that OP is smaller. Now we have one more radius you got, that is OP and OR. So here I can write point number 1. OP and OR are equal, that is radius of the same circle. Radii of same circle. Now if I see OQ, now OQ is a distance which is made up of OR plus RQ. Can I write this? So I can write OQ equals to OR plus RQ, that we have written the construction. Now from this, can I replace OR with OP? Definitely, because OP and OR are equal. So here I can replace OQ equals to OP plus RQ, and we can write the reason is from 1. Now from this it is very clear that OQ is greater than OP because OQ is OP plus RQ. So from this we can therefore OQ is greater than OP. This also implies that is OP is less than OQ. So we proved that OP is shorter distance. Now here you can find, so apart from P, if you take any point on the tangent AB which will be outside, you will get the same relation that OP will be less than OQ. So here we can have an argument and we can say that here of all line segments here drawn from point O to tangent AB OP is the shortest distance case of all the segments drawn from point O to tangent AB, OP is the shortest distance. Therefore, OP is perpendicular to AB. Therefore, OP is perpendicular to OB. So here all the shortest, so of all the line segments you are drawing from the point O to the tangent AB, you will find OP is the shortest distance. Therefore, OP will be perpendicular to OB. So I hope you have understood that we have proved this proof that if you have a tangent at any point of a circle, it will always be perpendicular to the radius. This theorem, whenever you go for application, you have to prove that. You can use this by saying that tangent is always perpendicular to the radius. I hope students you have understood the theorem clearly. Thank you all.